Hello friends, welcome you to this particular session on properties of logarithms. Up till now we have discussed the logs and anti-logs, how they are used and how to convert a number into its log, and how to convert a log value using the anti-logarithm table back to the original number. Now we are going to discuss some of the properties of logarithms. These are pretty easy ones, and some of these might figure in your exams as well, and you might come across them in the competitive exams also. Now the first property is log a base xy is equal to log a base x plus log a base y. Now have a look at this particular property and see, xy means x into y, no sign means there is x into y. So log a base x into y, if you want to expand it, you can expand like this: log a base x plus log a base y, right? Please ensure that the base is the same throughout. You cannot change the base in this particular property. So log a base xy, if you want to expand it, it is similar to log a base x plus log a base y. Then here it was basically a multiplication sign between x and y. Here it is the division sign, which means here x and y were being multiplied, here x is being divided by y. And how do you write it? When this is the term log a base x by y, x divided by y, you will have to do what? You will have to convert this into log a base x, and this would become minus log a base y. Minus because it is in the denominator, it is dividing x, right? So this is going to be the second property, log a base x minus log a base y. Don't get confused, please remember these properties. So this is the second property. Now what is the third property? Now this is a slightly different one, log a base x raised to power y. This is the power of x. Log a, this is the base, log a base x, x raised to power y basically. In such cases, what happens is, what you can do is you can bring this power to this particular side. So that is what is being done here. Have a look here, y into, there is no sign means there is multiplication sign there. So y is being multiplied by log a base x. So what you need to do is simply take the power from here to here and multiply it with the remaining portion. So y log a base x. Now please understand, the base is the same on both the LHS and the RHS. Left hand side and the RHS means the right hand side. A, here also, here also. So that is something that you have to keep in your mind. You cannot change the base while using these properties. Now let's have a look at one more property. This is if log a base x is equal to y. Suppose you have been given this particular relationship. It would mean that this x is equal to a raised to the power y. See how the numbers are getting transformed. So how the terms are getting transformed. Log a base x is equal to y would mean x is nothing but a raised to the power y. This is power of a. So what you have to do here, you remove log, you take a from here to here, so x will become a raised to the power y. Y is the power of a here, remember this. Then the fifth property, and this is again a slightly different one, so you should remember this as well, because you know these look pretty similar except for the multiplication, the division, or the plus and the minus sign. So the other threes are very different. Now this again is very different. So log a base x would mean log x divided by log a. So what is the meaning of log a base x? Log x divided by log a. Now you will have to remember these properties, and you will be requiring to apply these properties also. You would be required to apply these properties. How can you check whether these properties are wrong or not? I'll give you an example. Take the value of x is equal to 10, y is equal to 100, right? So this would become log a base 1000, right? And find out the value of log, and in place of a you take base as 10. So log 10 base 1000 would be 3. Here it would be log 10 base x value was 10, log 10 base y value was 100. So log 10 base 10 would become 1, log 10 base 100 become 2. So basically 1 plus 2 is equal to 3. So this is how we are going to check these properties. You can prove these properties also. So we'll take up one example. Find the value of log 10 base 20 plus log 10 base 5. Right? And I have told you that you basically need to remember three values. Remember log 10 base 10 and likewise log 10 base 5 and log 10 base 2. Right? If you remember these values, you can solve for all these questions. So these are the values that you need to remember: log 10 base 10, log 10 base 5, log 10 base 2, and possibly log 10 base 3 also. So these three values, please remember. You can find them out from the log table. Now we have to find out the value of this particular expression, log 10 base 20 plus log 10 base 5. Right? And you know the base is the same, and see, it looks very similar to this expression here. So what is the equivalent of this particular expression? Log a base x into y. So this is what I've done. Log, this was basically a is equal to 10, the base, x is 20 and y is 5. So this is same as this. So what I've done is I have written the equivalent form, and this is this by multiplying x and y. So I've got log 10 base 20 into 5 or log 10 base 100. This is fine. Now up till now we have found out the value of log 10 base 100, but we don't know the value of log 10 base 100 because we have to calculate it, then only we'll get our answer. So what we'll do, we'll be using this particular property here. Remember, log a base x is equal to y, then x is equal to a raised to the power y. Here what is happening, please understand, log 10 base 100 is equal to b. Right? So basically here this is a, this is x, and this is y. So we are using this identity, this property here. And now if you use this property, log a base x is equal to y would become, can be written in this manner also, x is equal to a raised to the power y, and that is what is being done here. X is 100, so I have mentioned it here, is equal to a raised to the power y means 10 raised to the power b. So this has been mentioned here, right? And this particular property has been used. This is property number 4 it was. Have a look again, this was property number 4. So we are basically using the property number 4, right? And then what we are going to do now, we have to find out the value of b. So what we'll do, we'll change this 100, convert this into this particular form, because then only we can make comparisons. So 100 can be written as 10 raised to the power 2. So this has been done here. 10 raised to the power 2 is 100. So I have made this change. And why have I made this change? Because I have to ensure that this portion is the same in both the terms or on both the sides of the equal sign. So what I've done is I've mentioned it as 10 raised to the power 2. Now since this is same, the value overall is same, this b is got to be equal to 2, and thus I have found out the value of b is equal to 2, and b was nothing but this was the value for this particular expression, or let's say the value for this particular expression. So in a way I have got my answer is 2, right? So you've got the answer 2. So the value of this expression which has been given here, log 10 base 20 plus log 10 base 5, basically it is 2, right? Now let me find out whether you can do this particular question or not. Find out the value of log 2 base 96 minus log 2 base 3. Now this time please understand, the base is different, it is not 10. So I'm just trying to tell you that the base may not always be 10, it could be 2, 3, it could be 17, 16, anything it could be, but you can use these properties anywhere. The only thing that you need to remember and keep in your mind is that the base should be same here, and on the right hand side also, just like a here, and here, right? So find the value of, now this is very similar to this, a is 2, you see that x is 96 and y is 3, this is fine. So basically this is very much like this, so I can further shorten it into this particular form. So I'll be doing that. Have a look at this now. log 2 base 96 by 3 x by y. So it becomes 96 by 3. You can understand x was 96, y was 3. So now, since this was a sign of, this was a negative sign here, so I have converted it into this particular form here. So now I've got log 2 base 96 by 3. When I do this, I divide this, it becomes log 2 base 32. And we are supposing it to be b so that we can further carry out our calculations. Now you remember this particular formula, again we are using this property number 4. If log a base x is equal to y, then x is equal to a raised to the power y. So if this is the case here, and let's assume here for a while that x is 32, b is y, and well, a is 2, right? Then y, a raised to the power y will be equal to x. So what I am doing is I am carrying this 2 from here to here, so it becomes 2 raised to the power b is equal to 32. And I am using the procedure which I had used last time. What we have to do is we have to ensure that this term here is same on both the sides. So what will I do? I'll write this 32 in form of 2, and 2 raised to the power b now will become 2 raised to the power 5. So I have written this 32 in this particular form, 2 raised to the power 5. Why? Because I wanted 2 to be here also, because here also there is 2, and this would help me compare. If all the other things are equal, then the only one variable which is there, that is also got to be equal. What I'm trying to say is if the value is equal on both the sides, the base here is also same, 2, 2, then b has also got to be same. This particular power has also got to be same, which means I'll get this idea that b is equal to 5, right? So I've got my answer here. This was basically reduced to this form, and this now is reduced to this form. So I know now that my answer to this particular question is 5, right? Now let me move on to the next topic, next property. Let's do an example of this particular property. Up till now we have basically discussed 3 properties. We have taken up examples, the multiply, the divide, and this one also. This also we have discussed because we made use of it while calculating the values in the 2 problems that we have discussed. Now we are moving on to the 4th property, and I hope you remember that this particular 4th property wherein y is a power of x, here we said that you just need to bring y to this side and then multiply it with the remaining portion. So this would be same as this one. So this is what we are going to do now. Log 3 base 81 raised to the power 2, right? So let us do this first. Let us first find out the value of this particular portion. We are not concerned about the power right now. So we are only finding the value of this particular portion. So again we have assumed that it is b, and again we are going to use the same formula here. You remember, we have been using it. We used it in the last 2 problems also. So now 3 raised to the power b becomes 81. And then what I'll have to do for comparison, I have to convert this into some expression with 3 in it. So I write it as 3 raised to the power 4. 3 raised to the power 4 means 3 into 3 into 3 into 3 is 81. So I have mentioned it as 3 raised to the power 4. The values are same. The base here 3, here 3, which means the value of b should also be equal to 4. And this is what I've got. I've got b as 4. But wait, this is the value of log 3 base 81. This is not the value of log 3 base 81 square. So what we are going to do now is log 3 base 81 square value has to be found. So what we'll do, we'll use this identity, we'll use this property to simply shift the power here and multiply it with the remaining portion. So 2 into log 3 base 81. Log 3 base 81, the value has been obtained from here, which is equal to 4. So my answer is 2 into 4, my answer is 8. Okay. So this is how you're going to apply this property also. Up till now we have discussed the 4 properties. A slightly different property we are going to discuss now. Find the value of log 7 base 7. Now this very property that we had used in the last 2-3 problems, we are going to make use of it to find out the value of log 7 base 7. As I said, base could be anything. The log table and the and please remember this particular fact, that the log table that has been given to you and the anti-log table given to you, or maybe the ones which you would be downloading from the internet, or maybe the one which is available in the annexures of your book which has been issued by the library, you would find that they are all with base 10. For other bases could be 2, 5, 6, there would be required a different anti-log table and log table. Is this okay? So now you have to find out the value of log 7, base 7. How do I do this? I'll be making use of this particular property. See, I'm supposing it to be b, and you can now understand this x looks like 7 and this y is basically b. So what will happen? I can mention this x in this particular form, so I can mention this 7 as 7 raised to the power b, and this is what I'm going to do. So 7 raised to the power b becomes 7. You know that the values of both the expressions is same, the base also is same. This time we don't need to make any changes, the base is also same, and you can now also make the comparison. B looks like 7 means basically 7 raised to the power 1. 7 raised to the power 1 is 7. So 7, if written all alone, means 7 raised to the power 1, and if you compare, you will get the value of b is equal to 1, right? Now let us do one more question. Find the value of log. Now this one is also important, log 7 base 1. How do I find this? I'll be making use of similar approach. I'll be using the similar theorem property. So log 7 base 1, we are assuming it to be c. Why not b? So that you don't get confused between the two examples. So I'm using c. And using the same property here, now what I'll do, I'll write 1 is equal to 7 raised to the power c. So I've mentioned that. Now, however, the bases are different here. That was not the case here. Here the bases were same, 7. Here the bases are different. Here it is 7. On the right hand side it is 1. Can I convert this 1 into 7 in some form of 7? So I'll do that. If you remember that any number raised to the power 0 is equal to 1, as long as this number is a finite number. If it is raised to power 0, it is equal to 1, right? Which means 7, I can write 1 as 7 raised to the power 0, because 7 raised to the power 0 is same as 1. So why am I writing this as 7 raised to the power 0? I could have written 6 raised to the power 0, that would also have been 1. 100 raised to the power 0 would also have been 1, but because I want to make comparison, so I am mentioning it in the form of 7. So 7 raised to the power c is equal to 7 raised to the power 0. Bases are same, the total value is also same, so c has got to be 0. So you will get the answer as 0. So log 7 base 1 will be 0. The answer would be 0, right? Now let us apply the properties that we have learned till now to solve a little more complicated problem. However, it's not as complicated as it looks like. Have a look. Log 10 base 200, 10 base 6 minus 10 base 12 plus 7 base 98 minus 7 base 2. How many of which can you solve straight away using the first or the second property? Can you do anything of this sort in these two terms? Can you multiply them together here? Do you have any property for this? You don't have. Why? Because the bases are 7 and 10, which are different. However, you can do this. You can use the properties for this particular operation, right? And that is why, and likewise here also we can actually perform this operation here and here, because the bases are 7. So this is what I've done. I've put them into brackets just to make you understand that we can perform these functions, perform these operations on these three, because the bases are same. So based on the bases, I have actually put them into separate brackets. So there is a second bracket in which the base of both the terms is 7, right? Now what we are going to do next is, this becomes log 10 base 200 into 6 divided by 12, and this one becomes log 7 base 686 divided by 2. I hope you remember the formula. We have discussed the first and the second property. Log a base xy is equal to log a base x plus log a base y. So that is why a base x plus a base y would become log a base x plus x into y. And this is what I've done here. this portion is basically the right hand side, so I have converted it into the left hand side, right? Now have a look. 200 into 6, you understand why, but why minus log 10 raised to the power log 10 base 12 has been put here because of this particular second identity, second property. So the simple method for you is to do what? You please multiply the terms which have been added up in this particular form. You multiply those terms, and the terms which have been subtracted, you simply put them in the denominator, right? So now this becomes log 10 base 200 into 6 divided by 12, and likewise here it becomes log 7 base 686 divided by 2, right? Here I have basically used this particular formula only, right? So now we are moving ahead. Log 10 base, we have cancelled 6, 2, and then 2 cancels out 200. So basically this becomes log 10 base 100, and this one would become log, when you cancel out these two terms, you will get 343. I hope you are doing this on your notebooks also. So log 10 base 100 plus log 7 base 343, but now we cannot use this formula because the bases are different. But can I find the value of these two? I think I can give it a try. So what I am going to do next is I am making use of this particular property. So log 10 base 100, it becomes 2. How would it become 2? 10 base 100, assume it to be, let's say, j. So 10 base 100 equal to j would mean that 100 is equal to 10 raised to the power j, and this will give you j's value to be 2, right? We have already done this in the last slide that we took up, so you please do it on your own. So I am not actually doing the calculation for you, you have to do it on your own. Likewise, see, log 7 base 343 is equal to 3, and that is why 7 raised to the power 3 is equal to 343. 7 into 7 into 7 is 343. So basically now I have converted these two terms, and now I have got 2 plus 3, which is equal to 5. So now this is my solution for these kind of problems also. So the task for you now is to keep on practicing such questions, so that whenever these questions come up in your exams, you are able to solve them. This particular portion, the one which we have discussed today, would not be appearing in your test, which are slotted for Monday the 25th. Rather, I'll be giving you another test somewhere around Thursday on the topics we discussed today, or on the properties of logarithm and how to perform the various operations of logarithm. Thank you very much.